So we are in the mini unit. Okay, so reducing radicals. I'm going to show you two different ways. One way is more of a shortcut way. The other way is the way that I prefer, because sometimes when we're doing the shortcut way, we don't always find the correct numbers that we need to find, and I'll explain that here in a second. This is the non-shortcut way, okay? Or I'm sorry, this is the shortcut way. So I give you a problem that has 2 square roots of 27. 27 is not a perfect square number. So if I were to type it into my calculator, it would give me a decimal answer. We don't want a decimal answer because typically the decimal answers we get from radicals are non-terminating decimals, meaning that they won't stop, and they're non-repeating decimal answers also. So we would have to round it, which would not be as accurate as us just reducing them. So one way to do it is, you're given the problem. The number under the radical, you find the largest perfect square number that goes into it. So perfect squares would be like 4, 9, 16, 25, 36. So like 2 times 2, 3 times 3, 4 times 4, 5 times 5. All those are perfect squares, right? So into 27, the largest perfect square number that goes into it would be 9 times 3. So you split it up into 9 times 3. Then what you do is you take the square root of that largest perfect square number. So like, what is the square root of 9? 3. So what happens is that 3 comes out because we took the square root of it. Can I take the square root of the number 3? No, it would give me some funky decimal answer. So what happens is that guy gets left in the radical. Okay? Then the last step would be to multiply anything on the outside of the radical and anything on the inside of the radical. So here I would just do 2 times 3 to give me 6 square roots of 3. And this is your final answer. Okay? Now, if you struggle at pulling out the largest perfect square, this is what I typically do. I just break down, so I have 2 square roots of 27. I'm going to break down 27 into any factor pair. So what times what equals 27? So 9 times 3. And what I'm going to do is I'm going to keep breaking down the factor pairs until I get to the prime factorization of the number. Who remembers what prime factorization means? The what? Correct. The lowest possible factor string that multiply to that number. So prime factorization means my last line are all multiplication of prime numbers that equal the number we are talking about. So that would mean I would break down 9 again. What does 9 break down into? 3 and 3. I cannot forget to bring down this other 3. Okay. Now, I'm at the prime factorization because these are all prime. 3 times 3 times 3 does equal 27. So you're done at that point. So what you do is you circle any pairs. So I have a pair of 3. What is 3 times 3? What's the square root of 9? 3. So 3 comes out of the radical. So one of those pairs comes out. I'm left with whatever doesn't have a pair, which is the square root of 3 left in the radical. Bring down my 2 from the outside. What's 2 times 3? I get 6 square roots of 3. Okay? So, for instance, let me think of one real quick. Square root of 32. What does that break down into? 8 and 4. Typically, we think of 8 times 4 before we would think of what's another factor pair with the largest perfect square? 16 and 2. Sometimes it's not as easy to find the largest perfect square number that goes into one. If I did it with the largest perfect square, what's the square root of 16? I'm left with square root of 2. However, if I didn't think first that to break it into 16 and 2, I would now break up 8 and 4. What does 8 break up into? 4 times 2, right? What does this 4 break into? 2 times 2. Are they all prime? No. So I need to break 4 up again. What does 4 break up into? Now bring down all your other numbers. Go through and circle your factor or your pairs. I have one pair of 2s. I have another pair of 2s. Okay. What comes out from this pair of 2? What comes out from this pair of 2? What stays in? So that's gone, and I've dealt with that, and that's now here. What's 2 times 2 on the outside? Square roots of 2. So we're going to get the same answer. It just depends on if you can pull out the correct factor pair. Okay, so I want you to go to page 5 real quick. Oh, I'm sorry, page 3. We essentially just did number 1, didn't we? What was our answer? Just put the answer in. Go ahead and try number 2, square root of 20. Square root of 20 breaks down into what times what? 5 times 4. Inevitably, or not inevitably, but on this one, you have to break it down with its largest perfect square number, right? 4 is the largest perfect square. So at that point, if you knew that, you could just pull out the 2 from that 4 and have 2 square roots of 5. If you broke it down more, you should get this. I have a pair of 2's. What comes out? What's left in? And that's our answer. No. Okay, so good question that I haven't brought up yet. Could I break it down differently? Yes, I could break it down into 10 times 2. 10 breaks down into 5 times 2, right? I bring down this 2. I still have a pair of 2's and I have a 5 because your prime factorization from any number, the very last row will always be the same. So you'll get the same answer. Perfect. So you'll get this answer too. I want for you to skip over to what's called page 4 on this packet. Let's look at number 16. Let's break it down. 9 breaks down into what times what? 3 times 3. What does x squared really mean? Okay, so write those down. What do you have a pair of here? 3, and I have a pair of x, right? So what comes out? 3 and an x. That's gone, that's gone. Do I have anything left under a radical? No. So it is okay to have nothing left under a radical. That is not square root of 1. Yes, it would be square root of 1. So if they put something into Schoology, that would be square root of 1. Okay, because what is the square root of 1? 1. And if you multiply anything by 1, what do you get? Right. Let's look at 20. How many C's do I have there? 13. So I'm literally going to write out 13 C's. And then I'm hoping that you guys get to the point where you don't have to write these out, but I want you to see the pattern. Okay. How many pairs do I have here? 6. So how many C's do I take out? So C to the 6. What is left over? So square roots of C. So C to the 6, square root of C. So essentially in any variable, you're seeing how many pairs go into their exponent, and then if you have one left over, then you put that in the radical. Will you ever have more than one of the variables left over in the radical? Like, could I have C squared left over in the radical? Why not? Then that would be a pair that I could have brought out. Or C to the 3rd would have a pair in it, and I would have brought one out, right? Let's look at 27. Let's break 8 up. What does 8 break up into? 4 and 2. Okay, so 4 and 2, but then 4 breaks up into... Okay, so 8 is one of those ones that I do a quick thing with, and I break it up right away into 2 times 2 times 2, because 8 will always break up into 2 times 2 times 2. And I feel like it takes too long to break it into 4 times 2 and then 2 times 2 times 2. Okay, and then I have 8 x's and 3 y's, right? So what do I have here? A pair of, what else? Yep. How many pairs of x's? And then what else do I have? Yep. So what comes out? And what do I have left in the radical? And all the x's are gone? Yes. 23, look at 23. What is the square root of 5? What is the square root of 25? What is the square root of 36? X squared, square root of x squared is? Square root of y to the 8th is? Do I have anything left over in the radical? No. There's my answer. Are we getting it? Or are we doing okay? Okay. Go back to the first page where we took notes. It is. Okay. Adding and subtracting square roots. You can only add and subtract square roots if they have the same number over the under the radical. So like I cannot add 5 square root of 3 plus 2 square roots of 7. That would be your final answer. You can't reduce down 3. You can't reduce down 7. You can't take the square root of them. I don't have apples and apples to add together. So this is your final answer. However, if I had 5 square roots of 3 plus 2 square roots of 3, I could then add those. So if I have 5 square roots of 3 and I add 2 square roots of 3, what do you think I'm going to have? 7 square roots of 3. It's like if you have 5 x's plus 2 x's, you get 7 x's. This radical number does not change. Okay? So if they give you a problem like this, 95% of the time, the radicals are going to reduce down to where they are the same, and then you'll be able to do the operation. So that's what you're going to have to do. Separate both. You're going to have to reduce them down. So 98. What times what is 98? Yeah, it gives you a clue right there, guys. It tells you. 49 breaks down into what times what? Times, yep, and then bring down the 2, right? I have a pair of, so 3 is already on the outside, then I'm going to multiply it by that 7 from the pair. What am I left with on the inside? 2. What is 3 times 7? So 21 square roots of 2. 8. Well, 2 square roots of 8. 8 breaks down into, we already talked about this. 2 times 2 times 2. I have a pair of 2's. So 2 is already on the outside. What else do I bring to the outside? And then what's left on the inside? So now 2 times 2 on the outside is how much? Square roots of 2. I'm going to add these two. Oh, no, I'm not going to add them. What am I going to do to them? Subtract them. So there's actually a mistake over here, guys. This 8 should be a 4. What is 21 square roots of 2 minus 4 square roots of 2? So there's also a mistake in the answer. That should be 17. Go to page 5 and try 31. $27 breaks down into what times what? 9 breaks down into? Bring down my 3. I have a pair of? Square root of? 75 breaks down into? 25 breaks down into? Bring down my? I have a pair of? Square roots of? The operation is adding. If I add those two things, what do I have? Awesome. Good job, guys. Your work right now. On pages 3, 4, and 5. 3, 4, and 5. You're going to do problems 1 through 36, the ones that we have not done. You have the rest of class to do this, though. Plus, anything you don't finish is homework. Can you use a calculator on this?
Yeah.
You can. Are you allowed to use a calculator on this? No. Whoever said yes, don't be a turd. Okay.